Gold is one of the most coveted and fascinating metals on the planet. We see it shining in jewelry, gold bars, and even in essential technologies we use every day, like mobile phones and computers. But behind its shine and value lies an incredible story: the process of extraction, transformation, and refinement of this precious metal. Have you ever wondered how gold travels from deep within the earth to your hands? What steps are required to turn ordinary rocks into valuable objects like an engagement ring, a bank gold bar, or a microchip? In this video, we'll take you on a complete journey through the process of gold extraction. From the first stages of mineral exploration to extraction, recovery, refining, and its final transformation into jewelry and high-tech electronic components, step by step and clearly explained. Get ready to uncover the secrets behind one of the world's most desired metals. If you're passionate about science, technology, or simply curious, stay with us until the end. And if you enjoy this kind of content, don't forget to subscribe, leave a like, and share it. Let's begin our journey to the golden heart of the earth. Step 1. Exploration. Locating gold deposits. The first step in the gold extraction process is exploration, a crucial phase that determines the success of the entire mining project. It's not just about digging anywhere. Locating gold deposits requires extensive research and the use of advanced technology. Geologists and mining experts conduct field studies using methods such as geological prospecting, satellite imagery, ground-penetrating radar, and chemical analysis of soil and rock samples. These studies help identify areas where geological conditions are favorable for the presence of gold, such as quartz veins or specific rock formations. Once these areas are located, exploratory drilling is carried out to extract subsurface samples. These samples are then analyzed in laboratories to determine the quantity and quality of the gold present, as well as the economic feasibility of the project. Exploration can take years before confirming whether a site is suitable for mining. In addition, during this process, potential environmental impacts are evaluated, and plans are developed to ensure sustainable operations. Without proper exploration, the costs and risks of extraction would be far too high. That's why this first step is so essential on the journey toward gold. Step 2. Extraction. How gold is taken from the earth. Once a viable deposit has been identified, the process of extracting the gold-bearing ore begins. Depending on the location and the nature of the deposit, mining can be carried out either through open-pit mining or underground mining. In open-pit mining, large excavators remove massive amounts of soil and rock to reach the ore veins. In underground mining, tunnels and shafts are built to access the deposits located deep within the earth. The main goal at this stage is to break and extract the rocks that contain gold. To achieve this, carefully controlled explosives, heavy machinery, and specialized techniques are used to maximize ore recovery while minimizing the impact on the environment. After extraction, the ore is transported to processing plants where its transformation will begin. It's important to note that, at this point, the gold is still mixed with other materials, so the extracted rock fragments must be crushed and prepared to release the gold contained within. This stage is essential to move forward toward obtaining the pure metal that holds such great value in the global market. Step 3. Crushing. Preparing the ore for dissolution. Once the gold-bearing ore has been extracted from the earth, a crucial stage begins: crushing. The main goal of this process is to reduce the size of the rocks that contain gold in order to release the tiny particles trapped inside. To achieve this, large crushing machines apply enormous pressure and force to the material, breaking it down into increasingly smaller fragments. The ore goes through several stages of crushing. First, large rocks are broken into medium-sized pieces using primary crushers. Then, those fragments are sent to secondary and tertiary crushers, which pulverize them until they are almost turned into dust. This size reduction is essential because the finer the material, the easier it will be to separate the gold in the following stages of the process. In addition to freeing the gold, crushing maximizes the surface area for the chemical processes that come next, such as cyanidation. This ensures a more efficient and profitable extraction of the precious metal. Although it might seem like a simple step, crushing is vital to guarantee that no gold particle remains trapped within the rock. Step 4. Cyanidation, the chemical process that dissolves gold. Once the ore has been crushed into a fine texture, it's time to extract the gold it contains. To achieve this, a chemical process known as cyanidation is used, one of the most effective and widely applied methods in the world. In this stage, the pulverized ore is mixed with a solution of sodium cyanide and water. The cyanide acts as a chemical agent that bonds with the gold, dissolving it and forming a liquid known as the gold-rich solution. This procedure is generally carried out in large tanks called leaching tanks, where the ore is constantly agitated to ensure that the cyanide comes into contact with all the gold particles. Depending on the size and concentration of the ore, this process can last from several hours to several days. Cyanidation allows for the recovery of a large portion of the gold contained in the ore, but it must be handled with extreme caution due to the toxicity of cyanide. That's why modern mining plants have strict control systems in place to prevent any environmental damage. Once the gold is dissolved, the next challenge is to separate it from the solution to obtain pure metal. Let's keep discovering how they do it. Step 5. Recovery. Separating gold from the mineral mixture. After cyanidation, the gold is no longer in solid form within the ore but dissolved in a liquid solution. The next step is to recover that gold and separate it from the other components. To do this, a process called adsorption is used, where the dissolved gold is captured using activated carbon or special resins. These materials act like a kind of chemical magnet that attracts and retains the gold particles. The gold-loaded carbon is then removed from the tanks and goes through a process called desorption, where hot solutions or specific pressures are applied to release the gold from the carbon, returning it to liquid form, but now much more concentrated. This gold-rich solution will then be treated to recover the metal in its solid state. Efficiency in this stage is crucial, as it ensures the maximum amount of gold is recovered before moving on to the final refining. In addition, the activated carbon can be reused several times, making the process more sustainable and cost-effective. Now that we've separated the gold, let's see how it's transformed into the shiny metal we all know. Step 6. Refining, purifying gold to its purest form. Once the gold has been recovered from the solution, it's not completely pure yet. It still contains small amounts of other metals such as silver, copper, or iron. To achieve the desired level of purity, the refining process begins. This stage transforms the gold into an almost completely pure metal, ready to be used in jewelry, electronic circuits, or cast into high-quality bars. The most common method of refining is smelting. The gold is heated in furnaces at temperatures above 1000 degrees Celsius, allowing it to melt and separate from the impurities. These unwanted materials, known as slag, float to the surface and are carefully removed. In other cases, to achieve even higher purity, electrolysis is used. In this process, the impure gold acts as an anode that releases particles of pure gold onto a cathode, forming layers of extremely refined metal, with purity levels exceeding 99.99%. This step is essential to ensure that the gold possesses the ideal characteristics of strength, malleability, and conductivity that make it so valuable and versatile. Now that the gold has been refined, let's see how it's transformed into the final products we all recognize. Step 7. Manufacturing, creating gold bars, jewelry, and electronic circuits. After the gold has been refined and purified, it's ready for its final use across various industries. The first common destination for refined gold is the creation of bars, high-value, high-purity metal blocks ideal for international trade or as a store of wealth. These gold bars are traded in global financial markets and play a crucial role in the world economy, as gold is considered a safe haven asset. In the jewelry industry, refined gold is combined with other metals such as copper, silver, or palladium to create alloys that increase strength and durability. These alloys make it possible to craft a wide range of jewelry, from rings and bracelets to necklaces and earrings. The combination of metals also allows for different colors and finishes, giving each piece its own unique character. Gold also plays a vital role in technology. It's used in the production of electronic components, such as integrated circuits and electrical contacts, thanks to its exceptional conductivity and resistance to corrosion. This makes gold indispensable in devices like smartphones, computers, and many other electronic systems. From the depths of the earth to the jewelry we wear and the technology we use every day, gold goes through an extraordinary journey. Each step, from exploration to the creation of gold bars and electronic circuits, transforms this precious metal into something truly essential to our modern lives. Now that you know how gold is extracted, are you surprised by how much effort it takes to produce a single piece of jewelry? Tell me in the comments, which part of the process amazed you the most? And if you enjoyed this video, don't forget to like and subscribe to discover more fascinating manufacturing processes. See you in the next video.